Okay, let's continue. So now the total annual worth cost for the year, which we need to estimate, we estimate actually for every year, like for the first year until we reach to the lowest annual worth cost. Let's see. So the current, again, the current market value is used for P when the asset is a defender, and the estimated future MV values are substituted for S values for 1, 2, and 3. So the market value is considered the salvage value once I say I will buy the machine this year, regardless of the real service life of the machine. Okay, the example is a 3 years old backup power system is being considered for an early replacement. Its current market value, its current market value is $20,000. Estimated future market values and the annual operating cost for the 5 years are given in table. So this table gives me the market value. So no need to estimate the market value. Okay. If you see, it decreases like 20% until the fourth year. Okay. What is the economic service life of this defender if the interest rate is 10% per year? Okay. And he gives me a random, it is not uniform annual costs, but or annual operating cost, but they are, like you see, they are random costs, like negative 5,000, 6,500 until 8,000, 12,500. Okay, to calculate the economic service life, we just estimate the annual worth for every year. For every year. We understand that, if you remember, we said the annual worth curve is like this, which means I need this point. Here, the economic service life. What does this mean? This means the first annual cost or annual worth of the total cost is high and decreases until a turning point. This turning point represents the estimated or the economic service life. Once it increases again, I realize that I have the economic service life. Okay? What we do is I estimate the annual worth for each year. Like at the first year, I have my cash flow like this. At the first year, the initial value, the market value, which it has given to me, which is after 1 year, and this is 0. This is B. I have annual cost here, the first year, and I have the salvage value, which is the market value. Salvage value is the market value. Do you remember the market value? Yes. In the first year, it is $10,000. Becomes $10,000. What I do is applying the cash flow analysis using this equation. Let's make an example for the third year, which, as you see from our table, gives us the economic service life is 3 years, which means I can keep the machine for 3 years, for 3 more years. Okay, for 3 more years. You know, so now P given A, I said now for the third year, I have the new cash flow like this. The cash flow is the salvage value now is for the third year 6,000. This is the market value. Okay? And twelve 20,000. Okay? For the third year, 6,000. So what we are doing right now is changing this to annual cost for 3 years, and the 6,000 is the salvage value for 3 years. This is the market value, 6,000. Okay, and I have three annual costs. I sum them together, but I make them together to the present. I transfer them to the present. Then their sum, I can change it to the annual analysis. So I just multiply by 3 years. So the first one is 5,000 P given F, 5,000 after 1 year, after second year, and after the third year. So 5,000, this, I'm sorry, this is negative actually. It should be negative. These should be negative. So I just do this. Negative 5,000, negative 6,500, and the third year is negative 8,000. Okay, what I'm doing now is transferring every point in this cash flow to 0 to make it P, like 5,000, P given F, 10%, and 1 year. This 5,000. And this is 6,500, same as 6,500. And this is 8,000. Okay, I first bring them to the B and transfer every single point or their sum to A given P, 10%, and 3. I think we have done this before in the cash flow. So 5,000 P given F and 1 because it's the first year, 6,000 P given F and 2 because it's the second year, and 8,000 P given F and 3 because this is the third year. The 6,000 here is the market value. The market value, the salvage value at the third year. Okay, once I estimate this value, I have the lowest annual cost, which is, if you see, for the first year we have 17,000, then decreases to 13,000, so decreases again to 12,500, then it increased to 12,900, then increases. So it became like this. The first year is 17, second year is 13, third year, I'm sorry, 17 is here. This is first year and this is second year. 17 and this is 13. Then it decreases to 12, then increased again to 1290, then start to increase again. So the economic service life is 3, which gives the lowest annual cost. Okay, and this is the solution through the Excel sheet. Like you see, this value is 12.5, this point. Okay, so now we learned how to estimate the economic service life. What would we do if we have two machines or two alternatives, mutually exclusive alternatives, and we need to decide whether to select the challenger or to keep the defender. So the difference between the economic service life and traditional annual worth is actually if the information is given, every data is given like a specified work or known project life, first cost at year zero, salvage value at year n. So a constant or varied annual operation cost. So we use directly the annual worth analysis. If we don't have market change, market value change, we don't have, we know that the first cost at the year number zero, the salvage value is always at year n, and we know the project life is n. Like we have the very traditional cash flow. So we easily use the annual worth analysis, and these A are all A, they do not change. So we use annual worth analysis and it works for replacement because it's comparing among alternatives, but everything here is fixed. Everything here is fixed. So we use annual worth. Once we have this is not fixed and this is not fixed, and there are some change in the salvage value, we don't know the estimate life of or the expected life of the machine or of the alternative. So it means that we cannot use the direct annual worth, but we use the estimated the economic service life. Okay. Mm. Okay. Now we start to perform the replacement analysis. The replacement analysis. What is it? Usually we have two different replacement analysis based on the study period. Okay, based on the study period. If the study period is not specified, okay, we use the economic service life, as we said. We use the economic service life analysis. So we estimate the annual worth for the defender, and we estimate the annual worth for the challenger. We select the smallest annual worth for between each of them. Okay, so if the annual worth of the defender is less than the challenger, so it means that I select the annual worth of the defender, or I keep the defender and I do not use or buy the challenger. If the annual worth of the challenger is less than the annual worth of the defender, I replace the defender and I buy the new machine or start the new project. The other study of replacement depends on the study or specified study period. And we said we can directly use a traditional annual worth analysis and or even the present worth analysis are also option. Okay, and we select based on the annual worth or present worth analysis. We have done this on the previous chapters. Okay, okay. We have some replacement procedures. Usually, we do the replacement study every year. Okay, we do the replacement study every year because life changes, technology changes, people perceptions change, customer change. So it means every year I should do the new replacement study. And actually, because every year there are many variables affects the economy and affects the industry, there are many replacement changes. That's why we have 1, 2, and 3 steps when we do the replacement study. In our class, we just make it simple and use only the first part here. So you are only required to do the first part for a new replacement study, which means on the basis of the better annual cost for the challenger or the defender, we select the challenger or the defender. When the challenger is selected, replace the defender now. I select the challenger, so I replace the defender and expect to keep the challenger for the NC years. What is the NC years? The economic service life of the challenger. This replacement study is complete if I do that for this year. Okay? If the defender is selected, okay, so we plan to retain it, we keep it for ND. This is the economic service life for the defender. Now I finished for this year. I need to make it for the next year, for the third year, for the upcoming years. So we have a replacement analysis and we call it 1 year later analysis. Okay, so we determine if all estimates are still current for both alternative or we have some changes. Firstly, first cost, market value with annual operating cost. If not, we don't have the same analysis. We just jump to step 3. If yes, okay, and this is the year ND. This is the last year of the economic service life. Replace the defender. Once I'm estimating the replacement and I know this the third year, like let's say this is 3 years, and I know that this is the third year, I just directly I know that the economic service life for this machine is 3 years. Now it is the third year, which means I should replace it. Okay, if this is not the ND years, we retain the defender for another year and repeat the same step and repeat the same step. Every year we make it until we say, okay, now we use the challenger or replace the defender with a new challenger. Okay, this step may be repeated several times. Okay, whenever this is the third step. Okay, if we don't sell, we don't sell with the data is changing. Okay, if the data changes, it means whenever estimates have changed, update them and determine the new AWC or the annual worth for challenger, the annual worth for the defender, and initiate new replacement study in step 1. What we understand, usually we make the first step. Okay, we make the first step. We have after the first step, this is the first year after we use the machine. Okay, then 1 year later there are some changes, some variability happens because of the new technologies or something like this. If there is no change, okay, we compare based on the years, number of years, the economic service life. If there is a change, we move directly to the third point and we use the new changes to estimate the annual cost and the annual cost for the defender and for the challenger. Let's take an example. The example says 2 years ago, Toshiba Electronics made $15 million investment in a new assembly line machinery. It purchased approximately 200 units at $70,000 each and placed them in plants in 10 different countries. The equipment source, tests, and performs insertion order kitting on electronic component in preparation of for special purpose circuit boards. This year, new traditional industry standards will require a 16,000 retrofit on each unit. In addition to the expected operating cost due to the new standards, coupled with rapidly changed technology, new system is challenging retention of these 2 years old machines. So all of the above is just like a study or a case study for a replacement problem. So far, these data are not useful. Okay, so the chief engineer at Toshiba USA realizes that the economic must be considered, so he has asked that a replacement study should be performed this year and each year in the future. This is what we need to understand or to learn majorly from this class. We perform the replacement this year and each year in the future. If need be, the I percent is 10% and estimates are below. We have a challenger and its data. We have a defender and its data. Like you see, the future market decreasing by 20%. What does this mean? It means that after 1 year, the cost or the market value is 50,000 multiplied by zero point 0.2 and so on. The estimated retention period no more than 10 years, which means I cannot say how long, but I know that it is not than 10 years. It is not than 10 years, more than 10 years. Okay, but I don't know. It is not specified. Okay, the annual operating cost estimates 5,000 in year one, increases 2,000 per year thereafter. So this is arithmetic ingredient. Defender current international market value is 15,000. Future market is 20% again. Estimated retention period is not more than 3 years. The annual operating cost is 4,000 next year, increasing by 4,000 per year thereafter, plus 16,000 retrofit next year. Okay, plus 16,000 retrofit next year. What are the requirements? We know that determine the annual worth values. This is not a big problem. Once we estimate this, we need to perform the replacement study right now. Then he changes after 1 year the data, which means we use step 3. We move to step 3 because the data has changed. Okay, so we move to step 3, or it means we make a new replacement analysis. So let's see. As you see, the results here are given by an Excel sheet. Okay, we use the same equation to estimate for A and B the annual worth for every year. Now, these analyses are for the challenger for the fourth year. So we have the challenger and we have the defender for the fourth year. Why it cannot be the so this is for the challenger. Why it cannot be for the defender? Because actually he said the defender cannot stay or cannot be kept for more than 3 years. So this is for the challenger. We know that the first cost is 15,000 and this is salvage value. Actually, this is negative 15,000. Okay, and this is 20,000. You remember this? This is the salvage value for the fourth year, which means it is 15 multiplied by 0.2 for this is for the first year. Then for the second year, we multiply it again for 0.2. Then for the third year, it's multiplied by 0.2. And for the third year, so this is 0.2. For the third year, we multiply it by 0.2. So this number equals to 20,000 480 for the fourth year. This is the market value of the alternative after 4 years. Again, if you remember, this is A, does not change, and the 2000, let's get back. The 2000 is G, so here is G, A, and G. So it's easy to estimate this because we don't need to make it P given F, because it is like this. The project is like this from the first year to the fourth year, from the first year to the fourth year, and we have here 15,000, and the salvage value here is 5,000 multiplied by 0.2 to the power 4, which is 20,480. And we found that for the fourth year, the cost is 19,123. For the Defender, we found that we estimate everything for the Defender and for the Challenger. Let's see here. The minimum annual cost for the Challenger here is negative 19,123 at the fourth year, which means the fourth year is the economic service life. Is the economic service life for the Challenger. On the other hand, the third year here is the economic service life for the Defender. Economic service life for the Defender, while the annual cost is 17,307, which means the annual cost for Defender, the minimum, let's say, the minimum annual cost of the Defender is less than the minimum annual costs for the Challenger, which means that we keep the Defender for 3 more years. For 3 more years. Until we start to pay more money because the annual cost increases, we stop and we do our replacement analysis again. This if the data does not change every year. But what if the data changes? We have a new cost analysis. This is for the C point. Okay, this is for the C point. The data has been changed, so we have a new market value for the machine 2, for the Challenger, okay, or for the Defender, okay. So now the data changes and we have a new estimates. You are not required to do this in the exam, but now the solution is the new Defender costs are negative 20,000, while the annual cost of the Challenger does not change. Okay, let's return back to the requirements to see what happened. He said after 1 year, it is time to perform follow-up analysis. The Challenger is making large inroad to make the electronic component assembly equipment new international standard features built in. The expected market value of the Defender. Now, the Defender data has been changed. Now the market value became 12,000 this year. Okay, but it is expected to drop virtually nothing in the future. So 12,000 next year, to the market value 12,000 next year, on the worldwide market and zero after that. So it's zero after 2 years. This prematurely outdated equipment and so more is costly to keep serviced. So the estimated annual cost next year has been performed increased from 8,000 to 12,000 and to 16,000. 3 years for the 3 years, 8,000, 12,000, and 16,000, which means the defenders costs start to increase. Perform the following replacement study. Now he keeps the challenger data the same, so we don't need to change this analysis. We just study the economic service life for the defender, which we have done for now, and 2 years later, okay, and this value for the annual cost, and therefore we found that the minimum annual cost turns to negative $20,000 after changing the data from the point C is negative 20,000. The ND is 2 years, yes, but the annual worth of the defender, okay, is more than or higher than the annual worth of the challenger right now. So this means I will replace the defender by the challenger, and the challenger can be kept for 4 more years. For 4 more years. And so we finished our lecture. Thank you very much.